In this lecture, we will discuss about the convolutional neural network. So before earlier classes, we have discussed about ANN and multi-layer ANN also we have discussed. In those, we are taking some neurons and we are taking some hidden layers in case of multi-layer, and we are taking binary or multi-class problems, and we are processing the data and finally classify the what is the output. But these are the number of features are very limited. Example, if 3 features were there, we are taking 3 neurons. If 5, they are taking 5. But when image comes, image consisting of several features because it is depends on the your number of pixels. If I am taking any pixel that is HD quality, then this many number of pixels were there. Each pixel having some important features. So all important features we have to extract. In those cases, if I'm using such type of neurons is very, very difficult. Okay. It is huge complex will increase in the network. And if I'm example whether any object is there in the image or not, if I want to identify, then I have to use the binary classification. But the input neurons we have to take this many neurons. And hidden layer also, if I'm at least half of the neurons, if I'm taking in a hidden layer, each connection has to be established in between the each neuron, and it will raise the complexity. So therefore, our ANN and multi-layer ANN, it is not suitable for the image classification. So by the way, they have introduced convolutional neural network. So here the convolutional neural network is the, if I am taking any image, because any photo you have taken from your camera, that has to be converted into the some data. Okay, it is a binary data, uh, and that means each pixel. If I am taking only our image consisting of 9 pixels, our camera can capture only 9 pixels. So each pixel having some information. If it is a color, then RGB, that is we can call it intensity. Okay, intensity. If it is a black and white picture, then grayscale. So for better simplicity here, I am taking only grayscale images because if it is a grayscale intensity level is 255, then it belongs to white. And grayscale intensity is 0, it belongs to black. In case of RGB, then 3 layers has to take for one for R, one for G, and one for B. For while extracting the features, we have to consider all these 3 layers. Okay, but here for the better simplicity, I have taken only grayscale images. Okay, now what are the steps to implement the ENN? First, we have to take the input matrix. Whatever the picture you have taken, that has to be converted into the matrix. Later, we have to extract the features. Extract the features. For this one, there are several filters are available. According to different filters are available in the Python libraries. These filters are used. Example for the if I want to detect any object, human being, then we need edge, shape, and texture also. These 3 filters are we are applying on this image to extract the features of the human being. Like that, several filters are available according to the applications. So after getting the features, even though the size of the feature matrix is very high, of course, very high. So again, we have to reduce. For this one, we are using pooling concept. Here, the pooling layer will further reduce the size of the feature matrix by retaining the important features. Simply by retaining the important features. So after reduce, then we have to apply for the flatten. Flatten simply, it is a 2-dimensional matrix into or 2 or 3-dimensional matrix into single dimensions. That is, if it is example 1 1 1 1 is there, Then we have to convert it into the. After this one, we have to give it to the fully connected layer. Fully connected layer is simply named it as our ANN. Now, there is n number of features are converted into the very limited number of features. This now, if I am example taking these are the 4 features, then you can use 4 neurons. If you want to any hidden layer, you can use hidden layer. And if it is a binary classification, you can use 1. If it is a multi-class, you can use 2 or 3 neurons. Then you can give that. From here onwards, so you might have known that this is ANN only, ANN, and again we have to classify. If we are finding loss is more, then we have to go for the back propagation. So this is the complete architecture of our CNN. First is the input matrix we have to take. Then from the input matrix, we have to take the filters. Filter is generally available. So example, if the filter size is example 1, 1, 1, 0, 0, 0, minus 1, minus 1. Like this, there are some different filters are available. These filters we have to impose on our input matrix to get the features. After this, at here, even though the feature size is very, very high, so we need to reduce by using the pooling concept. Here poolings are, there are 3 types. Uh, it's a max pooling, mean pooling, average pooling. So 3 pooling concepts are available. By using these pooling concepts, again we have to reduce the matrix size. Then we have to apply for the flatten. And finally, this flatten output we are giving to the fully connected layer, that is our ANN or multi-layer ANN. Okay. Let us see one problem. So here the definition is for the CNN is the CNN is a class of deep learning model primarily designed to process the data like with grid-like topologies such as images. Okay, whatever we have discussed. Okay, this is the input image. Whatever some image I have taken after converting it to the binary, this is the data. Okay, and here I made it completely normalized. This is 1 stands for let us take white color and 0 stands for black color. So something there is a image we need to find. Okay, here I have taken the one filter -1, -2, -1. That is the one. There are several filters available in Python libraries, and I have taken this filter. Now we have to apply this filter on the convolutional pattern. That means example how I will tell you that if there is a matrix 1, 2, 3, 4, 5, 6, 7, 8. Okay, again 1, 1, 1, 1, 1. Okay, 1, 1, 1, 1, 1. And the filter size is let us take 1, 1, 1. 3 by 3 filter I am taking here. Okay, this simply it is an element operation. That means this filter just superimpose on this because it is a 3 by 3. Now see, this is 3 by 3. Now simply element multiplication. It is not a matrix multiplication. It is element wise multiplication. That means 1 multiplied with 1. Sorry. Plus 2 multiplied with 1 plus 3 multiplied with 1 plus 6 multiplied with 1. Again, middle of this one, it is middle. 7 multiplied with 1. 8 multiplied with 1. Likewise, again 1 multiplied with 1 plus 1 multiplied with 1 plus 1 multiplied with 1 plus 1 multiplied with 1. Okay. So here you will get the 1 plus 2 plus that is 6, 6 so 12, 12 and 19, 27, 28, 29, 30, 31. So answer is 31 for this block. After this one, what you have to do, it is called as a stride. That means this block that is superimposing on this one, just move to the by 1. That means now again it will be like this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 1, 1, 1, 1, 1, 1, 1, 1. Now this filter I just this portion has been completed. Okay. Now next portion is this one, because all features we need to extract with the same filter. So this just I moved this block by only 1 unit. Now it will come like this. Okay. Just this is called as a stride. Stride one means we how many units we are moving towards either towards right or towards down. Okay. So first for this one we got 31. Simply I am writing over here 31. Okay. Next one, if I am multiplying same 2 cross 1, 2 multiplied with 1, 3 multiplied with 4, 1 and 4 multiplied with 4, like the same operation if we are continuing. If I am example I got 25 like this. Then next is the this filter we have to keep upon this layer, that means like this. Again we are getting some results. Let us take 21. So right side is now I am moving down by 1 unit. That means this time I am going like this 678 111 111. After this one, again we are getting some results, maybe 22. Like this, again, if there is a further downside, then we can go down one. Otherwise, we don't have any values at bottom layer. Again, we have to go towards the right side. Now this is and this one again multiply with the filter, and next one is a 3 by 3. This one is so like this you will get the some results. Okay, 38. Like. So this is the feature matrix. By this way, convolution applied on the input matrix. Okay, this is a very important step in the CNN. Okay, so likewise, see over here, this is my filter, and the first layer I have taken 100001111. So and I multiplied. Our answer is 4. And next one is I moved to the middle, that is towards one straight by 1. So this is 000 and 111. So I got 2. Likewise, if I am done for the all the input matrix, next one there and one by one. Okay, this here I have taken 5. So I finally I got this matrix. Okay, 420 620 300. This is the feature matrix. Features we have extracted from the input matrix. Okay, like this whatever here we have done. Okay, now next I said come to this one. First we have to get the features. Okay, but still this matrix having but we have taken very simple image. But sometimes what will happen, what I said, a very large number of neurons are required. Here only 9 neurons are required, but further we can reduce to 2 by 2 matrix, or even 1 by 1 1 by 2 matrix, like this, to reduce the complexity. For this one we have to use pooling concept. Okay, pooling, here I said pooling, what it does, 3 by 3 means simply there are max pooling, min pooling and average pooling. So if applying on max pooling on this 3 by 3, what is the maximum number? 6. That means only one feature will get 6. But it only one, with the help of the one feature, that means one neuron, we cannot extract the complete information. So that's therefore for the 3 by 3 feature matrix, we cannot apply the 3 by 3 pooling concept. It is a less than 3 by 3 can be applied, and always try to implement using square matrices only. So here I have taken 2 by 2 pooling. So 2 by 2 pooling means 4, 2, 6, 2. If I am taking max pooling, this one is a 6. Minimum pooling means answer is 2. Average pooling means 4 plus 2 plus 6 plus 2, 10 plus 14. That is 14 by 4. Okay, 3 point something answer will come. So next one is a towards right 2020. This is max pooling is 2, and 62306 and 2002. So finally, let us see over here. From the feature matrix, it is a number of neurons are required is 9. From the pooling concept, number of neurons are required 4. So we have drastically reduced the number of neurons. And after I said, after pooling, we have to go for the flatten. Flatten means simple, single dimensional. We have converted the single dimension, that is 6262. So this we have to apply for the our fully connected layer. Already you aware about this ANN, artificial neural network, or multi-layer neural. Here simple I have taken. I didn't go in deep about the this classification. So here I have taken 6262, then all weights I have taken, weights are given over here and biases also, and then simply I have implemented Z1 and ZD. Here I have taken 2, it means it's a multi-class problem. Maybe you can take it as a some car or bike, otherwise you can take apple or banana like this. So then we have to apply the one activation function. If you want multi-class problem means you have to implement this is softmax activation function. That formula for this one is the, you can take this e to the power of, there are two, Z1 and Z2. So e to the power of Z1 by e to the power of Z1 plus e to the power of Z2. And for the first one and for the second one, e to the power of Z2 by e to the power of Z1 plus e to the power of Z2. So here the percentage, the point, example, if it is coming 0.65, automatically it will come 0.35. So this is the answer. Means if example it is a apple, it is a banana. So as per the input information, the image consisting apple. If you want to say whether it is apple or banana, then answer is lights. Okay. So after this one, we have to apply the softmax. And if I am getting the proper answer, that is fine. If I am not getting the proper answer, again, you may aware that we have to find the loss, then go for the back propagation. Back propagation, by use, you can use stochastic gradient by updating all the weights and biases. Again, we are trying for the better outputs. If it is not possible, then we can further in the future iterations, we will get the proper outputs. So this is the explanation for the convolutional neural network. What is the advantage? Advantage is simply it is used for the image classification, any medical diagnosis, whatever the information from the picture, we can simply extract its features and classify with a minimal number of neurons. Directly can also be used, but it is very highly complex network will be required to implement, that cannot be sustained, cannot be handled by the our system. So that's why CNN is used for the image classifications. Okay, thank you.